Well done. Okay, and your 5 minutes starts now.
So WebKit has, can you hear me? So WebKit has a bunch of allocators. And previously they had tcmalloc, render arena, and so on and so on. And now the tcmalloc and render arena have been replaced by bmalloc. So fastmalloc now goes to bmalloc. Render arena goes to fastmalloc, so bmalloc. And B in bmalloc is bump. So it's a bump the pointer allocator. And so the implementation of allocate is you have this pointer next free, that's the result value that you're going to return. Then you add the size to that, you bump it up, and then you return the result. And for free, you do nothing. But then, so this will obviously leak all your memory. And so there are slow paths, but in 5 minutes I won't go into them. And for the demo, so this web core render table is a 130 byte object that I'm going to use for the demo. Okay. So here, oops.
Fail.
Okay, so this is actual code. So in addition to my simpler version, here they have a m remaining. So that's the count of how many remaining allocations they can make from here. But it's almost as simple as what I showed you, plus then the slow paths. And then all right, so this is free. And so basically, you don't just do a ret, but you push the object into this queue, and that's it. And then later, something in the slow path will do something, but it's very fast. So now I will demonstrate how this fastmalloc works. So here, so this where the objects come from, like the regions of memory where heap allocations are made from, they're thread specific, and each thread has so there's size classes, and in purple you can see the size class. So there's a place for 8-byte allocations, 10, blah blah blah, and so on, and then you have remaining. Now I just dumped this table, and this will be like if you ask for a 60-byte object. Actually, there's 0 remaining, but 68, then this will be the answer. And the one after that will be 68 more than that. So going into part 1. So indexing starts at 0, right, like in WhiskyCon. So now that's the table, but here, so I'm creating a bunch of render table objects, which are size 130, and you can see that, so this, you get one at 000, one at 130, one at 260, one at 390. So they're all sequential until this, when you have the line across, then that region of memory became full, and then you jump to a different place. And here you can see the difference between the sequential allocations, and it's 130 until then you go somewhere completely different. And then to finish off, so if, all right, oops, I should have, okay, here, so this was the first one, I just dumped the table. Here I created 1,000 of those elements. And here, so in the middle, I'm freeing 2, leaving 1, and then I'm making more allocations. So I'm making some holes in there, and actually then so the regions are, so here the regions originally are like this size, because this is like how much fits. So it's always C times 130 is like how many they have. But later, because I made these holes of, so I made these holes of 2 objects in the heap. Then later the slow path put these ranges that can fit 2 130
seconds
objects into the region where new stuff comes out, and now you always have 2, and then you go somewhere completely different. Thank you.
You can go on. Are you done?
Yes. That's the allocator. It's really that simple.
All right, Miaubiz, thank you. That was good.